Hello, let's do the New York Times Medium Sudoku for May 23rd, 2024. There's a link in the description if you'd like to try the puzzle yourself in the same Sudoku pad software I do. And I'm going to get started right now. Okay, so I make very few assumptions about what you know about Sudoku for these Medium tutorials, so I apologize if you already know all this, but I'm going to go over some terminology first. So we call these cells. There are 81 cells in the grid. It's a 9 by 9 grid of cells. And each cell we're going to be placing a digit into from 1 to 9. Now, there are restrictions that Sudoku give on what digits can go where, and there is only one solution. So we're given a bunch of digits to start with, and there's only one way to fill out the rest of the grid. And so we have to do that logically. We're not going to be guessing, because if you guess and you get it wrong, you're going to break the puzzle at some point. You won't be able to complete it. So what are the restrictions? Well, we have rows. That's a horizontal line of 9 cells. A row is made up of 9 cells. We have a column. That's a vertical line of cells. And we also have these 3 by 3 boxes that are bold outlined. There are 9 of each. There are 9 rows, 9 columns, and 9 boxes. Now, in every row, column, and box, we are to place the digits 1 to 9 exactly once each. So we can't omit a number from 1 to 9, and we can't duplicate one, no repeats. And that is what makes the Sudoku a puzzle. All right, so finally, I know it's a lot, but we have bands. A band is a row of 3 boxes. It's just a convenient way of talking about this structure. And then we have stacks, which is a column of 3 boxes. Again, just a convenience. There's no difference between a band and a stack. If you think about it, you can just rotate, just like there's no difference between a row and a column. If I rotated the puzzle 90 degrees, my rows would become columns, my bands would become stacks. But because we're looking at it in this orientation, we do refer to them in that way. All right, so the first thing we're going to be doing is we're going to be looking at bands. We're going to look at each band one at a time, and there's specific things we're going to look for. The first thing to think about with a band is how many of each digit do we expect to be placed in the band in total? And it's actually a pretty easy thing to answer because it's made up of 3 rows. And since each row has 1 of each digit, and there are 3 rows, we should end up with 3 of each digit. So we should end up with 3 1s, 3 9s, 3 7s, 3 6s, etc. So if we can find a digit that appears twice already in the band, then that significantly limits where the third one can go. So for example, we do have 2 6s in this band. So we have 6 here and a 6 here. Now that means this 6 is in the first row and this 6 is in the second row. So the last 6 will be in the third row. But in addition to that, this 6 is in the second box and this 6 is in the third box. So the final 6 also needs to be in the first box. So if it needs to be in the first box and the third row, it needs to be in the intersection of those, and it'll end up in one of these 3 cells. Another way we can prove that, which is a little bit more straightforward, but I wanted to give that sort of global look at that so you can sort of holistically understand what's going on when we're looking for these things. Because there's a lot of ways to think about things in Sudoku. But anyway, this box needs a 6 in it. It's got to put a 6 somewhere. And this 6 says don't put it in the same row, and this 6 says don't put it in the same row, and so we are left with just these 3 cells for a 6. But I like thinking about how we're going to end up with 3 of each, and they're going to be limiting where each other can go, because that's a really nice way to think about overall how the band is going to resolve. So we can't just guess which one of these ends up 6. We know one of these 3 cells will be a 6, but we're not going to guess which one. We're not just like place a 6 here and hope for the best. Instead, what we're going to do is we're going to use notation to remember this. And the notation I'm going to use is called a corner mark. Now, SudokuPad supports corner marks and center marks simultaneously. That's why I like this software. So we are going to use corner marks. And what corner marks will always mean is that within the box, we have limited a digit to this list of cells. So within this box, the 6 is limited to these 3 cells. And it just talks about the box. It doesn't talk about the row or the columns or anything like that. In this case, it is also limited in the row, but the markings are always related to the box. The corner markings are. And so this is how we're going to remember that. Now, I only recommend corner marking digits in boxes if it's down to 2 cells in the box. You can always mark it. If it's down to 3 cells, only if they're all in the same row or all in the same column. In this case, they're all in the same row, so that was markable. If you start marking up too much, then you start missing the most important marks. You can't see the I don't know if the phrase "you can't see the forest for the trees" actually means what I think it means, but anyway, you can't find the needle in the haystack might be a better way to put it. Oops. You want your haystack to be small and full of needles. All right. So what we want to do is we want to find all of the digits that repeat twice, or that appear twice in the band. And so what I recommend doing is comparing each box against each other box. So how many comparisons is that? Well, box 1 against box 2, box 1 against box 3, and box 2 against box 3. That's 3 comparisons. I recommend starting with the box with the fewest givens in it. So in this case, we have the 1 and the 9. And then look for those digits in the other two. Is there a 1, 9 here? Is there a 1, 9 here? No, there's not. So we've done 2 out of the 3 comparisons already. Now we just have to compare these two against each other. Pick of the 2 which one has the fewest givens. We look for 6 and 7. We do find that there is a 6. We already took care of that one earlier. But this is when we would have at this point. And there is no 7. So 6 was the only repeat in this band. Sometimes you have no repeats. Sometimes you have a bunch. You never know. Depends on the puzzle. So you guys got to look. And then the other thing, before we move on, other than finding duplicate digits, there's 2 other things I want you to look for in the band. Sometimes you find it, sometimes you don't. First thing is a completely filled box row. So we don't have any of those in this band. In fact, we don't have any in the puzzle right now. But it would be if we knew what all 3 digits were in a row within a box. We call that a box row for convenience. Again, just the names are for convenience so that we know what we're talking about in shorthand form. It's just like any other thing with a community, you end up with shorthand. But a box row, a filled box row would just mean that we know what all the digits are. We don't have any of those yet, though. Like if this was filled with, say, a 2, this would be a filled box row now. But it's not, so it's not. All right, so we don't have that. And then the last thing I want you to look for is a row or a box that has been reduced to 4 or fewer open cells. So for example, this row has 5 open cells. That's not 4 or fewer. This box has 5. So we don't have that either. So we are actually going to just move on to the next band. And we are focusing on the bands first. We're trying to get the low-hanging fruit first. There are other things you could look for and find, but we're going to do that on a second pass after we've gotten through the easiest stuff to see. And I know I'm taking my time in explaining, but actually this first pass can be done very quickly once you get used to it. And you're not sitting here explaining it. All right, so we do have, so we're going to compare this 9, 8 against these, right? We do have the 2 8s. And then here's where we're going to look up and down to see if we have any other 8s that might help. And we do see this 8 here. So that's where we're kind of leaving the band, is when we find the duplicates. We leave the band just to look here and here, just to see if there's any help. And so the 8 ends up in one of these 2, and we're going to corner mark that. And then when we compare the 3, 6 against this box, and we don't see any other duplicates. So there was just the 1 duplicate here as well. Any filled box rows? No. Any rows or boxes down to 4 or fewer? No. We move on. All right, 7 and 3, don't see them here. We've got the 1, 4, and 8. We do have the 2 1s. They look into here. We look up to see if we have any help from 1s up here. We do have this 1. That helps considerably because this 3 also isn't a 1. So now what we've discovered is in this box, there's only 1 place for the 1. Now we could corner mark the 1 there, but we don't need to because we know that this cell is a 1. So we can just place it because the box needs a 1 and there's only 1 cell that can be 1. And so it must be. And we call that a hidden single. Terminology-wise, hidden means we're referring to looking at the 9 cells in a row, column, or box. In this case, it was the box. And single means that we found that it was a single cell involved. And singles always allow you to just place a digit. There's only 2 kinds of singles. There's naked singles and hidden singles. And those are what allow you to place digits. Along with what sometimes people will use the term full house. If you have all 8 digits in a row except for 1, it's technically both a naked single and a hidden single, but it's kind of trivial. And so the most trivial thing is a full house. And you can fill that digit as well. And it's not called a single, but it could be. Anyway, that's a big tangent. But anyway, we placed the 1, which is very nice. And so that was the only repeated digit here. Did we fill a box row? We did not. Are there any rows or boxes down to 4 or fewer? Yes, there actually is. This row is now down to 4 open cells because we placed this 1. So if there's 4 open cells, that means there's 5 digits placed because that total is 9. And that means that there are 4 digits remaining that are going to go into those 4 cells. And we know exactly what those 4 are, even if we don't know exactly where they go. And so the 4 digits are going to be the digits that aren't the ones that are already in the row. So not 1, 2, 3, 4. There'll be 5, 6, 7, and 9. And what we're doing is we're looking for 5s, 6s, 7s, and 9s in their boxes, in their columns. And we're trying to find to see how things are restricted. So like one of the things I've noticed is we have this 9 here. So these 2 digits are not 9 because of the box. And so what we can do is use center marks to remember the stuff that we find interesting about an individual cell. So let's focus on this cell first, just as a demonstration. So what can this cell actually be? Well, we said for the row, we're going to need 5, 6, 7, 9. We also see that this cell can't be 6 or 9. It can't be 9 for 2 reasons. But anyway, let's just pick the column. Can't be 6 or 9. So if it said 5, 6, 7, 9, but not 6, 9, then we're left with 5, 7. So this cell has only 2 possible digits it can be, a 5 or a 7. And I'm going to use center marks to remember that. So remember, we use corner marks to mean things about boxes. Center marks mean things about individual cells. And specifically, they are the exhaustive list of digits that could still end up in that cell in the final solution. So the solution of the puzzle will have a 5 here or a 7 here. I'm not sure which, but it's one of those 2, guaranteed. And so, as a result, that center mark helps us remember that and is extremely useful for a lot of reasons. Now, my recommendation is to only center mark if you're down to 3 or fewer digits in a cell. 4 or more, it's just going to, again, it's going to crowd your puzzle. You're adding hay to your needle stack. So we want only needles in our stack if possible. Things that are definitely useful. And so because this row is down to 4 digits, anything that sees even 1 digit is going to be worth center marking. So remember, we were down to 5, 6, 7, 9. This can't be 9, so this can be 5, 6, 7. This can't be 6, so this is 5, 7, 9. And this can be any of 5, 6, 7. Oh, no, it can't be 7, sorry. So we can mark it. It can be 5, 6, or 9. I was going to say it could be in all 4, so we're not going to mark it, but there is that 7 there. All right. So, nice. We pencil this row, and when we do so, we want to think about all the digits real quick and just see if there's any interesting restrictions, like is 5, 6, 7, or 9 interestingly restricted. And in this case, they are not. So we don't need to do anything with that. But sometimes they end up restricted to an individual box, or sometimes there's only one place a digit can go. And then those are interesting situations. Sometimes you end up having pairs that will resolve another pair, things like that. Okay, so we didn't find any of that. So that is the last row or box with 4 or fewer cells. We didn't place anything new. And so we are done with this band. So we've done all 3 bands. We got a little bit of info, not very much in this puzzle today. But we still have the stacks. Remember I said stacks, rows are just like columns, bands are just like stacks. So we can do the exact same thing with the stacks, and it's going to be useful. So we're going to look for duplicates first. We have this 1, 9. The 1 is duplicated. So 1 is in one of these 2 cells. The 9 does not have a duplicate. We also have the 4, 5, and 8. Comparing against here, there are no 4, 5s, or 8s. So that's all the duplicates. Any columns or boxes down to 4 or fewer. This column is down to 5, unfortunately. So nothing to look at there. We can always come back and look at it later, but we want to find the low-hanging fruit first, right? All right, this stack, we have the 6 and the 7. So we do have these 2 6s looked out. That places the 6 in this box. Only one place for 6. A hidden single 6 in box 8. If you like the full spiel there. Now that we've placed that 6, the important thing to do is to remember what you've already scanned. And now we have new information about some of that. So we've already scanned this band, and the 6 is new information. So we want to check, does it have a buddy? Is there a 6 buddy? No, there's not. Did it fill its box row? No, it didn't. Did it cause its row or box to be 4 or fewer? No, it didn't. Okay, so no follow-ups on that 6 necessary, but it was worth looking for. So we did the 7, 6. We also have this 3. No 3s down here. So that was the only duplicate, just the 6. Just like up here. Interesting. And so now, did we fill any box columns? And yes, we did. We filled this box column. So what we want to do is we want to look at the 2 columns in the 2 boxes that this isn't. It's going to be 12 cells. You want to look for any digit there that isn't already in the box. Unfortunately, we just have the 6s. So we didn't find anything. But if we did, it would be very useful find. Unfortunately, we did not. All right, any columns or boxes down to 4 or fewer? Yes, this column's down to 4. We already know this can't be an 8, so it's already going to be helpful to think about. Let's see. After I sneeze. Oh, excuse me. All right. So this column needs a 2, 5, 8, 9. So this cell cannot be 8, so this is 2, 5, 9. This cell can't be 9, so it's 2, 5, 8. This cell can't be 5, so it's 2, 8, 9. And this could be any of 2, 5, 8, 9. So again, not super interesting, but we got some markings in. Adding some needles. So let's see. No other columns or boxes down to 4 or fewer. We found surprisingly little in this first pass. Sometimes that happens though. Sometimes we're sort of gated by a little bit more of an advanced spot before we can really find anything. All right, so here we've got the 8 and the 9. We do have these two 9s looking up, and this 9 looks in, so we can place the 9. That's very nice. Now remember to follow up, right? The 9 has a buddy now. It didn't last time we looked at the band, but now it does. So those 9s look in, putting a 9 in one of these two cells. Can't do anything with that yet, but it's still useful. We also filled a box row. So what do? We look at the 2 rows in the 2 boxes it's not. I know it's a funny way to put it, but I don't know a better way to phrase that. And so the 1 is not placed, the 9 is placed, the 7's not placed, the 6 is placed. So we have this 1 and 7. This is going to be super handy. Let's do them one at a time just for demonstrative purposes. But if I was doing this solve myself, I'd actually take them together, and I'll show you the reason later in a moment. So let's take this 1. What does this 1 do to this box? Well, it takes 1 out of these 3 cells. But this box row is also just filled. It's as if we had a 1 over here, even though we don't. It's as if we did, taking a 1 out of these 3 cells. And this one takes a 1 out of these, and this can't be a 1. We look down here for additional 1s, we don't see it. So we can actually corner mark 1s here. Now these 1s are going to do something called pointing. Pointing is when we've reduced the digits in a box to a number of cells, and those cells all share the same row or column. So in this case, the 2 places that 1 can be in this box are both in row 2. And what that means is the box is going to have a 1, and it's going to have a 1 in row 2. This is in row 2, this is in row 2. So row 2 cannot have any more 1s in it. Its 1 is over here, so it can't also be over here. So the result is that these can't be 1 in this box. We have this one looking in, and so 1 ends up down here. This one says not here. So we can corner mark that. And so actually that 1 buddy that we sort of imagined was down here to take 1 out of these 3 cells is actually true and always will be in this situation. And that's why it's super useful. We've learned that 1 can only be here or here in this box, which is not a trivial deduction. We also have this 9 here looking in. This 9, oh, sorry, not the 9. It was the 7. I was like, wait, there's a bunch of 9. What's going on? There's already a 9 in the box. The 7 looked in, and these can't be 7. So 7 ends up in one of these 2. Let's do the pointing first. So the 7 looks in. These 7s point in. We have this 7. So 7 ends up in one of these 2. But there's something else I want you to notice about this 1 and 7. Is there something special going on there? And what is the consequence? Might even be worth pausing and thinking about it if you're not sure. All right, so what's happening here is we have found what's called a hidden pair. Remember, hidden single was when there was a single cell in the box that could be that digit, so it is that digit. Well, a hidden pair is a pair of cells, 2 cells in the box that have 2 digits limited to them, and only them. And so it's like we have 2 hidden singles simultaneously, but they're kind of like, I don't know, like quantum state where they haven't been resolved yet. But we know that these are going to be 1 and 7, right? If we tried to put anything else here, like let's say we tried to put a 2 here, there's no immediate violation of the written Sudoku rules. There's not a 2 in its row, there's not a 2 in its box, there's not a 2 in its column. Seems fine to me, could be a 2. Why not? Why can't this be a 2? Well, the reason is if you look closely, this is the only cell that can be 1, and it's also the only cell that can be 7. We can't put both a 1 and a 7 in it. As soon as I put one of them in it, now there's nowhere to put the other one. If I put a 1 here, there's nowhere for 7. If I put a 7 here, there's nowhere for 1 because of this 1 and 7 here. So the result is that this can only be 1, 7, which means we can use center marks for that. And what the hidden pair did is it removed any other digit other than the ones involved in the pair from those cells. Now, if you think about it, a hidden single does the same thing. Removes everything except that single digit from the cell. So we thought there could be other digits that could go in here, and now we've proven that there actually aren't other digits that can go in here because we need to be able to place the 1 and 7 in the box. Now, the result of that is that these 2 cells aren't the 1, 7, right? And so they're the 2 digits that remain in the box other than the 1, 7. And so we can just fill that center marked as well. And we know one of them's a 2, and this 2 says not here. So actually now, because 2 was removed from these 2 cells, because of the hidden 1, 7 pair, that was my example actually. Now there's only one place for 2 in the box, and we can place it as a hidden single. And now there's only one place for this, what am I saying? For the 8 in the box, and that goes there. So we got the 2 and the 8. Alrighty. And now we have been scanning this stack. That's how we found we found all this. We placed, if you remember, we placed the 9, which then allowed us to find, we rescanned the band. It allowed us to find this filled box row, which then let us find this hidden 1-7 pair. So then let us place the 2-8. So we want to make sure we follow up on this band first because we were working on this final stack here. We're going to get back to it, but we want to follow up on this band. So we filled this box row as well, but it's not helpful anymore because if you think about it, what the filled box row did is it told us about what's going on in this box. We already know what's going on in this box. We're down to this 1-7 pair in these placed digits. The 2 and the 8 do not have buddies. We already did the buddy for the 9. This row is down to 3 digits though. So we're going to think about what those are. We're inevitably going to pencil all the cells because it is down to 3, but I like to think about it first. We need the 3, 4, and 5. So this can't be the 5, so it's only 3, 4. And by doing this one at a time, I'm actually thinking about what numbers are being used here and where they're ending up. So this is 3, 4, 5. So what I noticed is that the 5 is only in this row. The 5 is only within this box, right? We had 3 digits left. Sorry, 3 cells left. Only one of them is outside of this box too, and that one can't be a 5. And so the 5 is limited to these two. That's a nice way to spot it. So because the 5 is in one of these two, that does something called claiming. It claims the rest of the box saying it can't be 5. Because this row needs a 5. It's very similar to pointing. This row needs a 5. The 5 is in one of these two cells. But wherever it ends up, it will be in this box also. So if the 5 is here, it eliminates 5 from these cells. If the 5 is here, it eliminates 5 from these cells. So it doesn't matter where the 5 ends up in this row. These cannot be 5. So the result is that these can't be 5 specifically. Also, we do have pointing, right? This 5 looks in, and so this 5 looks up. And so 5 ends up in one of these two. Now, what did we just find here? I definitely want you to, if you don't know, I want you to pause and think about it as well. All right, hopefully I gave you enough time. This is a hidden triple. Remember, hidden means we're dealing with a row, column, or box. In this case, we're dealing with this box. Triple means we're dealing with 3 digits in 3 cells. So the 5, 6, and 7 need to go in this box somewhere, and these corner marks are telling us that they're only in these 3 cells. We need 3 cells for the 5, 6, and 7, which means we cannot put any other digit in here other than the 5, 6, and 7. If I try to put, let's use 2 again as an example. If I try to put a 2 here, look what happens. I can put like 6, 7 here, but now there's nowhere in this box for 5. I could, okay, well, let's put the 5 here then. Well, now there's nowhere in this box for 7. Now, if you remember, the 7 was limited because we have this 1-7 pair saying they can't be here. So don't get confused by that. But because of this 1-7 pair, these can't be 7 because the 7's over here. We need to put a 7 in this box. It prevents 7 from being over here. So this ends up being a hidden 5, 6, 7 triple. When we do that, we can convert our center marks we convert our corner marks to center marks. We don't need the corner marks anymore. So we end up with this 5, 6, 7 triple. Now that means that is the 5, 6, 7 also for this row. So these cells cannot be 5, 6, 7. So what are they? And we already know that, right? We have the claiming 5s, we have the 6 and the 7 in here. So these are the 3 digits left for the row. So they're the 1, the 2, they're not 3, 4, 5, 6, 7, and then 8. And so we see that this sees a 1 and this sees an 8. So if the 1, 2, 8 are here, they aren't here. This is a 1, 2, 8 triple, right? The 1, 2, and 8 will end up in these 3 cells. We know that for the row. You can also just look at these cells and see that it's a naked triple. By naked triple, what I mean is we cannot repeat digits in these cells because they're all in the same box. I'm using the box on purpose here. They're all in the same box. And so that we cannot repeat, like we can't have both of these be 1, right? We can't have both of these be 2. And so there are going to be 3 different digits. And if you just look, you say 1, 2, 2, 8, 1, 2, 8. What are the unique digits here? 1, 2, and 8. That's 3 unique digits. We need 3 unique digits for these cells, so those are the digits that go in these cells. These will be 1, 2, and 8, which means this cannot be 2 or 8, so it can only be 9. 2 and 8 have been eliminated. There's only one digit that it can be. It cannot be 1, 2, 3, 4, 5, 6, 7, or 8, so it must be 9. It doesn't matter that this can also be 9. It doesn't matter that this can also be 9. What matters is that this cell, it's a naked single. Naked meaning we're looking at the cell itself and nothing else. We're looking at the cell itself and what its list of values are that could be in the solution. Its list has been reduced to 1 value only. So that is the value it is. We make it big. It's a 9. That removes this 9 from here. It removes this 9 from here. I have noticed that by doing that, We actually have caused 5 in this column to be limited to these 2 cells. So I am going to corner mark that, and that is going to claim the rest of the box, removing 5. So that's something we want to remember. But also, this cell here has been reduced to 3, 4, or 5, but it can't be 5. So it's only 3, 4. Because it can't be the 1, 2, 8, if you recall. All right. Now also, this box here is down to 4 digits, and so is this row. It's going to be the same 4 digits. Because this 5, 6, 7 is here, right? So what are the 4 digits? We're going to think about it. 2, 3, 4, and 8. I'm seeing this sees 3 and 4, so this is only 2, 8. This sees an 8, so it's 2, 3, 4. This doesn't see anything, so we're not going to mark it. But we do know that the 8 is limited to these 2, so I am going to corner mark that. We also know the 2 is limited to these 3, so I'll corner mark that. All right, we got a lot out of the follow-up in this band, all because of what we noticed in this box. Now we're going to backtrack all the way to looking at this stack. We're going to follow up on that. We're going to redo basically our scanning because we just got a bunch of stuff. So the 8 and the 9, we have the duplicate 8 now. These 8s look down. This 8 looks in. 8's in one of these 2. The 9 we took care of. We have all 3 of them. We have this 1 and this 2. The 1, unfortunately, we don't know where it is. But the 2, we do know where it is. So we get a 2 in one of these 2. All right, did we fill up any box columns? Yes, technically, but we already know everything about this box, so it's not going to be helpful. No other box columns. Any columns or boxes down to 4 or fewer? I do see this column is 4, so let's look at it. We need 3, 4, 6, 7. Anything super special? I am seeing this can't be 7, so the 7 ends up here, and that is going to claim. So this is 3, 4, 6 then. This can't be 3 or 6. So this is only 4, 7. This can't be 4, so it's 3, 6, 7. I'm trying to remember what the digits were. 3, 4, 6, 7. Yeah, this can be any of them. But the 7 being here is interesting. It means these are not 7. We need to remember that. The first thing I'm actually doing, and unfortunately it doesn't help right now, is because the 7's here, we know it's not here. And so I'm seeing how full this row is, and so I'm wondering which of these can be 7. And this one can't be, but unfortunately, as far as I can tell, this cell can be 7. So we do not find a hidden single 7. 7's in one of these 2 cells in the row. We don't have a good way to mark that, so we'll just try to remember. We do. If we don't, we don't. Okay, so anything else with this stack? Columns or boxes down to 4 or fewer. Not seeing it. Okay, so we have finished our initial pass on scanning. We did not find everything we wanted to find. So what we need to do is we need to look a bit more carefully box by box, and we need to look for some more subtle restrictions that might be going on. So the way that I like to do that is just let's go each box one at a time, and we're looking internally into the box. We're going to do external scanning outside of the box as a third pass, which is the most advanced pass. And you're welcome to combine these together if you start feeling comfortable with them. But you notice this was the lowest hanging fruit. This was the easiest stuff to find in the puzzle. Now we're going to look for harder stuff. So the first thing I'm going to focus on is, first of all, I'm going to look at the corner marks I have in the box, and I'm going to make sure my center marks respected it. Because sometimes we just accidentally center mark something we shouldn't have. So the 2 and the 8 are corner marked in here. I'm just checking for 2 8s here. I'm also seeing that they point in the row. I'm checking for 2 8s over here. Don't see anything like that. The other thing I'm looking for is we have this 1 and 9. The 1 and 9, most interestingly, are avoiding this column. So I want to think about where 1 and 9 go in this column. We do have the 1 already, and the 9 can go here or here. So unfortunately, it's not one place, so we can't do anything with it. But it's worth looking, right? We want to be focusing on each digit one at a time. The other thing that I want to look for... that wasn't really something important to look for right now. That's kind of the external thing. The internal thing to look for is there anything here looking into the box that might be restricting us within the box? So the 1 or the 5. We do see the 5. Now we look over here for additional 5s, and we see this 5 here helping. It does mean 5's in one of these 2, but we already knew that from the 5, 6, 7 triple, but I thought I'd point out that that is there. Okay, yeah, I don't really see anything else that we can do here. I'll point it out when I do see something. This box, and in general, these boxes, we know everything about them, right? We have them marked up, so we're not really going to find much about it. The only thing I want to just double check is that we did respect our corner marks, and then I'll move on. Okay, this box might be more interesting just because we don't know much about it yet, so maybe there's something we didn't find that we should have. So we do have the corner marked 1s. We do double check that we've respected that. So we have this 4, 5, and 8. So I'm going to take each pair of givens, and I want to look at the row and column that they don't occupy. And I want to see if they're, so outside of the box, right? So this row and this column, when we're looking at the 4, 8, I want to see if there's any duplicate digits. Unfortunately, there's not. How about over here? Again, it would just be the 8. The 8's already in the box, so it's not helpful. So I don't think this box in general is helpful. We also have the 8 and the 5. We want to look at this column. We have the 3, 7, and 9 that might be interesting. And then we look for 3, 7, and 9 over here. This 3 does not count because it's in line with our 5, 8. So let me slow down a little bit because we just find something. Sorry, I'm a little all over the place here. Let me slow down a bit. This 5 and 8, I'm going to make them green. What's interesting about this 5, 8 is that they occupy the same row, but which means that they're missing a column. This column here passes right through them. It doesn't have to pass through. It just has to be a column that they aren't in. So whenever you pick any two givens, there's going to be a column they aren't in because two givens can't occupy 3 columns. Or if they're in the same column, then there's going to be a row they're not in. So in this case, we're looking at these purple cells. Now we don't care about things that are already in the box. We also don't care about empty cells. But the 3, 7, and 9 are not in the box yet. So those are potentially interesting things about how they're affecting the box. They're already removing those 3 digits from these 3 cells. There's only 4 cells left that can be 3, 7, 9. That's almost a hidden triple on its own. Unfortunately, it's not. Now, what we can do is, because these share a row, there's going to be 2 rows that they aren't in. We'll call that blue. We have the blue cells here. Now, we don't care about empty cells. We do care about pointing. If there's any pointing left, right, like this 8, we might care about it. But unfortunately, 8 we don't care about because there's already an 8 in the box. So it's just this 9. This 9 is not in the box. And it is duplicated here. So we're looking for a 3, 7, or 9 in these cells is what we're looking for. And we find the 9. So let's focus on that. We have this purple 9 taking 9 out of these cells, and we have this blue 9 taking 9 out of these cells. Notice how that is, they overlap in 1 cell. So notice how that's 5 cells that can't be 9 in the box, plus 2 more in the green, which are filled with non-9 givens. So actually 9 can only be in 2 places in this box. And that's super powerful. This is the kind of thing we're looking for on the second pass. You notice it involved a lot of external stuff looking in. But we do have these 2 9s, and these are going to point. The 9's in one of these 2 cells, which means it's not here. Importantly, it's not here. And this 9 says not here. This 3, 6 says not here. So we have a hidden single 9 in this box now. We cannot put a 9 down here anymore because it will remove 9 from this box entirely. So the 9 ends up here. We just place that. That does clean up 9 from this cell. When I do that, I'm seeing how I have this row marked up, and I'm looking to see where 9 can still go in the row. And the answer is only here. So we have a hidden single 9 here as well. Places that 9. Now when we place that 9, that does remove one of the corner mark 9s that we just placed actually, meaning that we have a hidden single 9 in this box now because there's only 1 corner mark left, so we can place it. Very nice. Now backing up here, that 9 removed one of the places that 6 could be, and now there's only 1 place for 6 in the row. Or you can notice this 5, 7 pair if you prefer, both of which would tell you that this cell is a 6. That does remove 6 from here, leaving only 3, 4. Now, if you remember, this was the satellite cell that we had these 3 in the same box plus this one. This one can't be 6 anymore. That means 6 is limited to these 2 and is going to claim the box. Okay, good stuff is happening here. Also, this 6 did buddy up with here, and it tells us the same thing. So however you want to spot that. We are left with this 5, 7 pair. So that was very powerful. We found the 9 in a bunch of places because of that. In fact, we found so many 9s, I just want to make sure. Yeah, so there's only 1 9 left to place. And so whenever that's the case, you can always place it. It ends up here. That was our final 9. All right, we placed a bunch of stuff here. Does that affect the stack or the band? The stack, I mean, we already have all our 9s. So we're not going to find more buddy 9s or whatever to do. We did get this 6. So we do have these 2 6s looking in. So there is a 6 in one of these 2 cells. We also filled up a box row here. And so we want to look here for digits that aren't in the box. It's only the 6, unfortunately. So we already got that. We filled this box column. Oh, that was a while ago, though. Did we cause any rows, boxes, or columns to be 4 or fewer? Is kind of the next follow-up question. I don't think we did. I'm looking. All right. So we're going to continue looking at this box now, just to make sure we don't miss anything. We did get a new 9. I don't think there's anything else to see though. Oh, you know what we did do is we placed this 9, which reduced this row to 4 or fewer. So let's look at that now. So we need the 1, 2, 4, and 7. This can't be 4 or 7, so this is only 1, 2. Which means the 4 and... Oh, okay, so now we have found... Remember when I said 7 was reduced to these two and we don't have a way to mark it, so we're going to hope to remember it? Well, I just placed a 9 in one of those places. So this row now has 7 in only one spot, only here, because these 7s are claiming the rest of the box. And so we have the intersection of this column says 7 can only be in these 3, and this row says 7 can only be in these 3. And so it has to be in the intersection of the two because they're all in the same box. We can't repeat a 7. So the 7 ends up here. These are not 7. This is not a 7. Now we're down to 3, 4, 6. We can just mark that. And this is down to 1, 2, and 4. So the 4 in this row can only go here because we have this 4. So that's the 4, and this is down to 1, 2 only. This cannot be 4 anymore. That's a 3, 6 pair. 4 in this column can only go here. All right, I think we finally found the things we needed to find. There's a few things to follow up on here. Let's start with this box because it's down to 3 digits. The 1, the 2, and the 5. Okay, so 5's in one of these two. I'm not going to bother marking that at this point. So 1, 2, 5. This column is down to 1, 5, 7. Can't be a 1 or a 7, so it can only be a 5. Now that's 1 and 7. That's 1, 2, 5, and 7. That's 5. Here I'm just following our naked singles using the red markings to assist me. So this is, but you can also just do this without the red marks. You just remember what you placed and make sure you clean up the center marks. It's much easier to miss things. I don't want to miss simple stuff like that in my walkthroughs. So anyway, that's a 2. Now, when we place that 2, it does remove this 5 corner mark, which is also red anyway. But we want to look for where 5 can still be in this box, and we see that this is the only place for 5 now. And that removed an 8 corner mark, leaving this the only place for 8. So you can just cascade that and place a bunch. Just be careful, because sometimes we do mark 3 in a box. Let's finish this row with the 1. Let's finish this whole triple. No, just the 8. We don't finish the triple. This can't be 5 anymore. That had a corner mark in it, so this is the only place for 5. All right, we've got a lot of progress here. We just placed a ton of digits. We placed a bunch in this band, so my recommendation, just kind of skip ahead and just pencil it. This band is just pencilable at this point, so we're just going to pencil it and see what happens. So we're down to the 1, 4, and 7. And this can't be 1 or 4. So this is the place for 7. These can't be 7. They're a 1, 4 pair. So if that's a 1, 4 pair, yeah, I guess that doesn't mean much. All right, what does this box need? We need a 2, 3, 6, and 7. So we know the 7 can only be here because of these 7s looking in. That places the 7 here as well. And what were the last digits? This is 3, 6 only. It can't be 3. I'm looking at the row and seeing this is only 3, 6. Can't be 3. So that's 3. Or sorry, that's 6. That's 3. That's 6. The 6 resolves the 5 and the 6 here. Resolves the 6 in this box. This is a pair. We need a 2 and a 3. Okay. So this band is you see what I mean? Penciling this band just kind of cleaned it up. We didn't need to worry about buddies and stuff like that at this point. All right, so now at this point, I'm just looking for really restricted rows, columns, boxes. If there are any, that's just kind of what to focus on. So for example, this box is down to 2 digits, right? Let's just pencil it. We need a 3 and an 8. So there was a chance it was resolved. It's not, but it's still useful. Here we need a 2, 3, and 7. Okay, I'm seeing that the 7 is limited. Oops, I meant to center mark. 2, 3, and 7. We can see that the 7 is quite limited. In fact, there's only one place for it. So we place the 7. 7s are actually done now. This is 2, 3, or 8. Can't be 3 or 8. So it is only 2. I'm looking at the row and seeing 2, 3, 8 is what's left. Can't be 3 or 8, so it must be 2. That resolves the 3 and the 8, the 3 and the 2. The 2 also resolves this 3 and 2. It places the 2 in this box and the 8 in this box, placing the 4 and the 3. This box is completely resolved. This box is resolved. And these 3 digits are 4, 5, 8. The 4 goes here. The 5 goes here. And the 8 goes here. And we're done. With the correct solution, of course. All right. So hopefully that was helpful. This was an interesting one because our initial pass didn't find much until the very end. And then that kind of cascaded. But even that wasn't enough. We had to go box by box. And the thing that we really needed to discover was how the 9 was limited in this box. We had to see the 9 passing through this 8, 5 and this 9 looking in. Not the easiest thing to spot, but these crossings are very, very, very useful whenever you spot them. Almost always. in my solves for the hard, I look for that as I go through the bands. But I feel like in the medium solves, it's too much to focus on all at once for someone learning. So I save that for when it's needed. I did actually notice a few crossings as we went, and I just didn't mention them. I figured we'd save them if we needed them. All right. So that is it for this puzzle. I hope you enjoyed it. I hope you're enjoying these walkthroughs. They do take me a good chunk of time to record, and I do try my best to explain as I go without assuming you've seen my other videos. So I hope that's helpful for you. I hope you're learning and you're improving. And of course, if you enjoyed this, why not leave a like, subscribe, and a kind comment below.